Alright, so we want to start with a clean slate. So what we're going to do is, like I showed you before, is click on Project and New. That will create a blank screen for us to start to put some information into. And if we look at the interface, or the graphical user interface, the GUI for QGIS, we can see that there's three main panels that we'll be dealing with. One's a browser panel, and this will be different for everyone's machine because it'll show your particular hard drives and folders within those hard drives, as well as some links to server databases where we can extract information from. We'll have a layers panel, so as we add data to our GIS, it's typically in the form of layers, and those layers will appear in our layer panel. That'll become a little bit more familiar as we add some layers in. And in here, in this particular area, this main viewing panel, this is where we'll see most of our data, and we'll be able to move our data around, magnify it, or zoom in or zoom out. And you can see up the top here that there's a bunch of buttons. If you leave your mouse over it, those buttons, it'll actually tell you what those buttons are. So that is a pan map. So say we had a satellite imagery on our main viewing screen and we wanted to move it a little bit, we'd use that button. If we wanted to magnify and zoom in, we'd use that particular button there. We can create with our Manage Layers toolbar. Now I've put the Manage Layers toolbar up there, but if you want to move any of your toolbars, you can see these little white dots. You can move them around to different parts of the screen that might make it more comfortable for the way you work. Just depends how you work and where you want things organised. So that's how you move those particular toolbars around. And if we hover again, we can see that the Manage Layers toolbar allows us to add in different layers that we might want to create from scratch. So we could create our own vector layer, and that vector layer might consist of a series of points. So say we wanted to map out water troughs or something like that. We could create a layer that called water troughs, and we could mark out the individual locations of the water troughs, provided our projection and datum have been set in the data, and I'll show you what they mean shortly. But essentially they're making the data such that we can put our GPS information onto that particular map. And if we work in different parts of the world, or even different parts of the state, we have different projections and datum, so it's important to get those right. But we'll explore those a little bit more in detail in a second. So the first thing we might try and do is actually add some satellite imagery data to our particular project. Fortunately, with QGIS, they've linked to a number of free data sources. So if we go up here and we click on Web, Open Layers plugin, we can see that we can download satellite imagery data from a number of different locations. This is obviously going to go out to the web to a particular server, so in this case Google Maps, or Bing Maps, or Wikimedia Maps. A bunch of them that have been built into the QGIS server interface so that we can actually go and get that information. One of the things that we'll choose, particularly if you're not familiar with an area, is if I was to use Google, I'd probably use the Google Hybrid Map, which would be a satellite map with some major road features overlaid. That allows me to help navigate a little bit easier. But I'm going to choose Bing Maps and Bing Aerial with labels. And you can see now it's connecting to the internet, and it's brought up a map of the world. On my mouse I've got a little wheel in the middle which allows me to zoom in and zoom out, and you can see that there is a little bit of lag when you're doing this. It's got to go and get that data, so depending on how many people are connected to the server, you may find it a little bit slow, or depending on your actual internet connection. I can actually also use the zoom in functions up here. So I can go and draw a little box by left clicking on my mouse and holding it. You see a little purple box appear, and I can highlight a particular area. So here I'm going to try and zoom into the Wagga region. See how, and you can see that I've just zoomed in a few times, and for some reason it's completely missed Wagga, even though I went right over the top of it, or maybe I didn't. Maybe I chose West Wyalong. But we will try that again and zoom in on the right area, Wagga Wagga. and you can see now I'm getting a bit closer to Wagga. So Lake Albert in Wagga, the main street down here, our Murrumbidgee racecourse, and the Murrumbidgee River that sort of goes through the edge of town here, occasionally flooding and causing some havoc for the people in North Wagga and the people in the lower lying areas near the river. Up here, if I grab the pan map tool, I can then slowly move around and we can see that we're locating the university in the first instance, and I'm going to zoom in a little bit closer to the uni so I can get a bit of a feel for where I'm at. Now you might be trying to do exactly the same thing for your particular farm, so you can start to put in things like fence lines or have a look at where your trees are. Your objective might be to map out your native vegetation or to map out your different paddock boundaries and your different areas that are being cropped or grazed, and so having a base map can be quite useful for doing that. So if I zoom right in here, where I'm actually making this tutorial right now is within the corner of this brown building. So that's aerial maps and how to get some of those onto your into your QGIS. You can also see down here that as I've added that layer in, it's been added into the layers panel. And if I right click on the layers panel, you can see that I've got a number of options within that. I can zoom to layer. If I click on zoom to layer, what it'll do is it'll take me back out to that entire layer. So that's not exactly the best for what I wanted to do right at this point in time, but we'll zoom back to where we need to get to. So bear with me while my internet catches up. And we're getting closer. So we're back up around the CSU campus again. You can see sometimes when you go too far, so if I zoom all the way in, the image is quite high resolution because I can see individual trees. Sometimes you won't be able to, but once you get past the resolution of the imagery, you'll get a screen that looks like this, which just tells you you've gone too far. Sometimes also you'll get those blocky white patches, which just means your internet's a bit slow and hasn't been able to download the data for that particular block. So one of these is what I'm referring to. So if you give it a second or move your imagery a little bit, it should refresh itself by reconnecting to the server and downloading that data. So much like digital photo, if we zoom right into our digital photo, our satellite imagery will be made up of a bunch of pixels. So it's spatially located, so it'll have a reference system that tells us where things are, or if there isn't a reference system, we have to set that reference system. And typically when we're talking about satellite imagery or data that's made up of these pixels, we typically call that raster data. That's just the lingo that we use when we're talking about spatial information. Raster data typically refers to those blocks of pixels, whereas vector data is usually lines, polygons and points that we may overlay over the top of our raster data. So one of the things whenever we start a project that we really need to think about is what's the reference system or the coordinate reference system that our data's using. So whenever you use a GPS system, you use a particular coordinate and projection system that basically tells you exactly where you're located. And in different parts of the world and even different parts of the state, they use slightly different projections and datums, and so it's you need to know which one you're using because there's slightly different measurements. So if we're using an older version, we might be actually 100 meters out from where we're meant to be. So to find it in QGIS, we go to Project and we go down to Project Properties, which will open a tab that looks a bit like this. And within this, it tells us a lot about our particular project. So if we go down to Coordinate Reference System, the CRS, we can have a look at what the project projection is, the coordinate reference system, the projection for the Bing data that we've downloaded. So it's in the WGS84 projection, and it's a Mercator projection if I look down here. If I click back on the General tab here, we can have a little bit of a look and select some of our properties. So one of the things that we want to make sure that our properties are actually using the distance unit in meters, because that's what we tend to be familiar with. We could measure in square meters, but most of us using or having anything to do with the land will probably be more comfortable with using hectares or acres. Hectares being a little bit larger for larger areas is quite useful. And we also want to make sure our coordinate display, so you can see these numbers down here. We want to make sure our mapping units are in decimal degrees, and then if we click apply and then OK, we should now, as we scroll around our map, have something a little bit more meaningful in terms of longitude and latitude for where we're located. So if I look at the CSU farm, we can see parts of the CSU farm starting here on the corner of Agricultural Avenue and Pine Gully Road. And if I hold my cursor across the top there and I look down at the bottom screen here, which I've just highlighted now, you can see that I'm highlighting some coordinates. So I'm going to, whoops, I've moved it around a bit. I'm just going to put my cursor down there, and you can see that I'm about 147.34 and minus 35 degrees 0.05. That's that particular location. I can also go and find some other intersection points, which I'll try and find for you. So if I tried to find you some intersections here and I headed north along Pine Gully Road, so we were located just down here where I've got the hand on the map, and if I go up here to the corner of Pine Gully and Brunskill Road, you can see down the bottom that I've got some coordinates that you could record for this particular exercise. Likewise, if I go up here to Pine Gully and Prices Road, you can see that those coordinates have slightly changed, so I should be able to add those coordinates in on the tutorial as well. We can also adjust the scale of our imagery by adjusting the scale box down below here. So you can see we've got quite a 1 to 20,000 scale at the moment. If I wanted to change that to 1 to 250,000, you just add the 250,000 into that box, 1 to 250,000, and you can see that that's now going to encompass quite a large area. If I change the scale to 1 to 5,000, I'm obviously going to get the area in much more detail that I'm looking at. So you can adjust the scale manually by entering in a scale, and then when I move that around, it locks in that scale. So if I'm comfortable with being able to identify buildings or features and I want to look at a map in that particular scale, I can lock in that scale, but I can also unlock the scale by clicking on that unlock. Sorry, I can also lock the scale by locking that button, or manually change it by clicking the unlock button there as well. So typically when we're looking at a large scale map, we show a small geographic area in a lot of detail. So the smaller that number, 1 to 5,000, shows a small area, but it shows it in very high detail. Whereas when we look at a small scale map, so say a 1 to 250,000, we cover a large geographical area, but in very low detail. So just what I've shown you in that representation. And we can obviously also add the scale of the map by putting a scale bar onto our particular map. So for the rest of this project, I'm going to set the scale to 1 to 10,000. It'll be quite useful for us to work at that particular scale, and I've entered that into the dialog box, and you can see it's refreshed the imagery at 1 to 10,000 scale.